So this is the second video of the rational functions. I'm going to go through problem 3 and 4 on the note sheet. We'll see how long it takes. Hopefully not that long. All right, so problem number 3, I'm going to jump right into it. Same setup, same exact things that we're going to do. So part number 1 here, I want to factor it and see if I can cancel anything. So x plus 2 is not going to factor. So I'm just going to leave it as x plus 2. But my denominator here is going to factor into x plus 2 times x plus 1. And so you might notice right away that the x plus 2's will cancel. So I want to write that simplified equation left over. So y is equal to, now this is where we've got to be careful. It's not x plus 1. You might be looking and say, well, that's the only thing that's left. And it is the only thing that's left in the denominator. All right, so we've got x plus 1 in the denominator. But we still need something in the numerator. So a couple things you can think about. If I take x plus 2 and divide by itself, I'm dividing out to 1, right? 5 divided by 5 is 1. Let me actually say the right numbers there. Any number divided by itself is 1. And so when we do this division, there is a 1 left over. The other thing you could think of is this factor of x plus 2 could have a coefficient of 1 sitting there. Whichever way your brain likes to work with it, make sure you understand that. All right, Y-intercept. We are going to set x equal to 0. So we've got y is equal to 1 over 0 plus 1, which is really just 1. And so when we completely simplify that out, we're going to have a y-intercept of 0, 1. Okay. X-intercept. So for the x-intercept, I am going to set y equal to 0, but really what I'm doing is setting the numerator equal to 0, all right? Because remember, the only way to make a fraction equal to 0 is if the numerator is equal to 0. So I have my numerator of 1 equals to 0, and at this point my brain says no. It says no because 1 is not equal to 0. And because that is not true, and it's never going to be true, in this particular problem, you do not have an x-intercept. There's just none. Okay? So let's do vertical asymptote first. So vertical asymptote, we're going to set the denominator equal to 0 and figure out what value needs to get thrown out of the domain. All right, so in this case, it's going to be x is equal to -1. All right. Now we're going to talk about the horizontal asymptote. So horizontal asymptote in this case is a little bit different because we don't have matched degrees here. We've got x on the numerator, x squared in the denominator. Or if you look at the simplified version, we don't even have an x in the numerator, and we're dividing by x in the denominator. So think about this again as the extremes. All right. Now again, not talking 100, not talking a million, extreme, a trillion, a billion, things like that, extreme values. So if I took $1 and I divided it by 1 billion people, everybody's going to get something. Now, what something they're going to get? They're probably going to get little microscopic shavings of pennies. If I took out a sander and started shaving up pennies, maybe we could divide it up. But you're not talking about a significant anything. So 1 divided by 1 billion, a trillion, whatever you want to think about, is a very, very tiny number. So tiny that we say it is approaching 0. All right, you're basically getting no money if I take $1 and divide it by 1 billion people. And this is going to be the horizontal asymptote for any time the higher degree, let me make sure I get those words right, higher degree is in the denominator. Hold on a second. I have a hard time writing this word apparently. Denominator. There we go. So if the higher degree is in the denominator, all right, you will always have the horizontal asymptote y is equal to 0 because when we talk about the extremes, this denominator will overpower everything else in the numerator, and so you end up with things like 1 divided by 1 billion. Doesn't work out to be a whole bunch of money. All right, so that's the horizontal, and let's talk about the discontinuity the hole here. All right, we do have a hole because we had something that we canceled. So I'm going to take that factor that I canceled, set it equal to 0, because this is another value that we need to throw out of the domain. but it doesn't get thrown out as an asymptote, it gets thrown out as a discontinuity. So a little bit different there because of the cancellation. To find the other half of the discontinuity, we're going to go ahead and use that -2 in the simplified function, and it has to be in the simplified function, or else you're going to end up with something divided by 0, not useful. Okay, so we've got all this information. I am going to go ahead and put it on my graph. Okay, so let's see. Y-intercept is 0, 1. X-intercept is none, so obviously there's nothing to draw there. Vertical asymptote, I am going to go ahead and put those in highlighter just so we can see it. I'm also going to kind of smush that down a little bit. So let's see. X is equal to -1. Let's go here. Y is equal to 0. Well, that's the x-axis. So let's go ahead and draw across the x-axis here. Okay. And my discontinuity is the point -2, -1. So I'm going to kind of zoom in a little bit. -2, -1 right there. Nice part about this particular graph is you will not need to get another point, because I know on the left side here I have to be going through or going and approaching this open circle, this discontinuity. So I know my graph has to be down in this lower left quadrant. And I know that on the right side here, I need to be in the upper right so I can go through the y-intercept. Okay, so your curves don't have to be amazing, but they do need to be curves. Okay, you need to make sure you're approaching the asymptotes, not crossing them. Okay, especially not the x-asymptote. I'm sorry, the vertical asymptote. Remember, those are the values that got thrown out of the domain, so we don't want to include them. So that's problem number 3. And I'm going to go ahead and slide on down to number 4 and finish this one out. All right, so problem number 4, we're going to start by factoring it. So x plus 4, x minus 1. I'm going to factor an x out of the denominator. That's the GCF. So these x plus 4s will cancel each other out or divide each other out, however you want to phrase it. So the simplified version is going to be x minus 1 over x. Y-intercept, we're going to make x equal to 0. I'm having issues writing apparently tonight. So x is equal to 0. So let's see, y is equal to 0 minus 1 over 0. This is undefined. And since it is undefined, it is absolutely impossible to graph that. So you're going to tell me the y-intercept here is none, because I have no idea where the point 0 undefined is, so we don't graph it. X-intercept, I am going to make the numerator, right, numerator equal to 0. So x minus 1 equals 0, which means x is equal to 1. So my x-intercept is 1, 0. Vertical asymptote, I'm going to set the denominator equal to 0, so x is equal to 0. There's nothing to solve there. It's done for us. So x is equal to 0. Horizontal asymptote, in this case, our degrees match. So x squared, or x and x. Doesn't matter which one you really look at. And all I want to do is divide the coefficients. So there's a 1 here and a 1 here. 1 divided by 1 is going to give me a horizontal asymptote of 1. So y equals 1 there. We do have a discontinuity hole in the graph. So take the factor that you canceled out, set it equal to 0. This is going to give us another value that we have to throw out of the domain. So -4 here. We're going to put that -4 into the simplified expression, right? Simplified equation here. So -4 minus 1 over -4. So -5 over -4, which is just 5/4. For your ordered pairs, please put the ordered pairs as fractions if you need to. Right? Use fractional values. But if you're having some issues trying to figure out where to graph them, feel free to pitch them into your calculator and get a decimal value, so it's easier to graph it. All right, so all of this handy-dandy information is going on my graph. Y-intercept, there is none, so nothing to graph. X-intercept is 1, 0. Vertical asymptote. Let me make sure that that's slightly smaller. Let's go there. X is equal to 0 is the y-axis, which is why you don't have an intercept there on the y-axis. Horizontal is y is equal to positive 1, so a little horizontal line there. And we have a discontinuity at negative 4, positive 5/4. So negative 4 means I'm going to slide over negative 4. 5/4 is 1.25, so 1 and then a little bit above your horizontal asymptote here. But remember, it's a discontinuity, so make it a hole in the graph. We're in the same boat that we were with problem number 3. You don't have to get an extra point because you know both the left and the right side of this graph. On the left side here, I'm going to go ahead and come down for my vertical asymptote, approach that discontinuity there, all right? And then on the right side, approach here, and then approach here. Okay. All right. So a little bit of practice here on figuring out all the bits, parts, and pieces. If you have any questions or concerns, send me a message or send me an email. I hope this helps.